This is a re-edited version of LeetCode 17, letter combinations of a phone number. In the previously uploaded version, parts of the screen were clipped. The diagrams for the recursive calls to DFS are now fully shown. Please enjoy the video. We're given a string of digits. Each digit must be mapped to characters from the phone number keypad. The digits are 2 through 9 inclusive. Just a warning, in JavaScript, we always must be defensive. We might not get digits 2 through 9 in the real world. So, looking at the algorithm, given the digits 2, 3, we need to output an array of strings where each character in that string is a mapping from its respective digit in order in that string. So for 2, 3, we'd get AD, AE, AF, BD, BE, BF, CD, CE, CF. So the first character in the string comes from the first digit, and the second character in the string comes, in our output strings, comes from the second digit of our phone number. And if we had a digit of 3 numbers of 2, 3, 4, we'd have AD, ADG, ADH, ADI, and so on. I'm thinking of this as a tree where ABC is the mapping from 2, and 2 has a child node of 3. 3 would be the next node in the tree from each mapping. So it wouldn't be so much that 2 has the mapping of to child node 3, but each character from each mapping in 2 has the child node 3. So almost as if 2 has a mapping to 3. So 2 has ABC, A has a mapping to the characters in 3. So A goes to 3, B goes to 3, and C goes to 3, because 3 is the next thing in our input string of 2, 3. And then we have to iterate. We go from A, and then we go to B, and then we go to C. But before we go to B, we have to go left in our depth-first traversal. So we're going A, and then we're going left to D, and then we're going to E, and then we're done with E, and then we're going to F, and then we're done. And we're going to the next one, B, D, E, and F. So it's almost as if we're iterating over child nodes, and for each child node, we're iterating over child nodes starting from left. And for each child node of D, we would iterate starting left. So it's a depth-first traversal algorithm. It's a little weird to wrap your brain around, and it took me a minute. So if you're struggling, don't feel bad. It is a little abstract. It's kind of hard. Hopefully that helps. So given our depth-first traversal strategy, we're going to try to optimize for tail call recursion in JavaScript. And we do that by using strict mode and having the last call in the function recursive. So there's nothing else after this DFS, and it's in a tail call position, so we can then use strict. And that will give us tail call optimization. The DFS function takes 2 parameters. The defaults are 0 and the empty string. We're going to build up that empty string until it matches the length of the phone number. And when it does, we're going to put that onto our answer. That's our loop terminal condition for our recursion. Our loop terminal condition for our for loop is when I is less than keychars.length. And that's going to be one of these in our keys array. So we start out with index is 0 and word is the empty string. Obviously index is not equal to the length of len, which is the phone number's length, so we go into our else block. Our else block, we get the key number from the phone number. Now in the case of the phone number 234, that's 2. Keychars is 2 minus 2 is keychars is 0. Is this one ABC? So it's the string ABC. We then loop through those keychars. Index is 0 plus 1. Word is empty string plus keychars 0, which is going to be A. So now we started out with 0 in the empty string. We're calling it a DFS again from this for loop for the first time in this for loop. And we're going to iterate through this for loop 3 times for each character in keychars. We're calling this DFS function again with 1 and A. So while we're still in this for loop, we're calling DFS again. So now we're going back into DFS. We're calling it with 1 and A. And let's see, is index less than equal to len? No, index is 1, len is 3. That's 2, 3, 4 is 3 length. So go into the else. Key number is phone number at index 1, which is now going to be 3. Sorry, we're going to get this one from 3. Sorry, no, phone number at index 1 is digit 3. So index is 1. Yeah, that's correct. And then we get 3, key number minus 2. Key number is 3 minus 2 is 1. So key's 1. And that is DEF. Now we're going to loop through again. So we're going to make another recursive call off of node 3. You notice how we went to 2, and then we made a recursive call to 3, and then we made a recursive call, and then we're making a recursive call to 4. It's just mapping to our tree. We're going left from node 2, and we're going to node 3. So we're in node 2, and we're making a call again recursively. Index is 1 plus 1, that's 2. Word is A, and key chars is again 0. So now we're going to pass in key chars 0 is D of this. Give this next key chars string. And we're going to have AD coming in. The length is 2, index is 2. We're not done, so we don't go through there. It's because we have to go to like 3. We're going to get the key number off of phone number 2, which is 0, 1, 2 is 4. That's the digit there. Key chars is 4 minus 2 is 2. And we go up to our here, 0, 1, 2. That's GHI, as we can see on our keypad image. We're going to then loop through key chars GHI, get the 0th one, which is G. And so now we're going to have ADG. We're then going to pass that. We have A and D plus G, it's ADG. We're going to pass that with 2 plus 1. Index is 2. And now we have 3. Now we have index is 3. Now index is len. Now we can push that onto our answer. Now we can pop that off the call stack, and we can go back to our loop. Index is 2 plus 1. Word is key chars. I is now 1. So now we have H. So we now have ADH. And we call that DFS again. And again, len is 3. We push that on. Now we have ADH. We finish that call. We pop that off the stack. We're done with that call of DFS. And when I say pop that off the stack, I'm talking about the call stack. So we're back to this for loop. I is now 2. Index is 2. 2 plus 1 is 3. And I is character 2. 0, 1, 2 is I. So ADI. We're going to call DFS with ADI. Length is 3. We're going to put ADI onto our answer. And now we're done with that. Pop that off the call stack. And back to our for loop. I is now 3, as we incremented it after that call. And now we're done with our for loop. And so now we're done with this else block. And so now we go back to our other call. As we can see down here, we have the initial call was 0, then we called it with A, and then we had AD, and then we had ADG, ADH, and ADI, and this is where we've just finished. And now we're popping this off the call stack, and we're going back to the prior call in that loop where we had AD, and now we have to increment D. So the character at D is now incremented, and we get the next one. So now I, in this second character, the second level in our tree, is now on the second character mapping, which is from DEF is now going to be E. So now I is 1, right? And so we're going to have 1 plus A plus key chars 1, which is E, the second one in there, index 1. And so then we're going to call that again. And we're going to pass in index 1, and we're going to pass in word plus key chars E, and we're going to call that DFS function again. We're going to call it with 2, and it's not quite ready yet, so we're going to go into our else block. We're going to create a new for loop, and we're going to back to this for node, our last node in there, because we still don't have length is equal to our phone number's length. Index is less than len. It's 2 instead of 3. So we're going to create a new for loop in this else block. I is 0. Key chars.length. Well, key chars, what is it for this last one? Well, we got the index is 2. 0, 1, 2. That's the 4 character of digit 4. It's a string, and we get that property off of 4 minus 2 is 2, and we get that 4. So okay, so that's the one we're going to get next. Is sorry, phone index is 2. Phone number 012 is GHI, and then we're going to get keys. Phone number is 2, 012. We get that 4-digit. Keys 4 minus 2 is 012. We're going to get this GHI, right? There's a lot to think about. Keep in mind on the stack. So we're looping through a keychar's GHI. We're going to get 2 plus 1 is 3. Word is AE plus keychars at index 0, which is going to be G. So we're going to get ADG is going AEG, sorry, AEG. Little copy pasta there. And then we're going to go through AAD, and we're going to next one we're going to get is ADH. As you can see, this pattern iterating through, and then we're going to go to AEI, and then we'll be done with 4, and then we'll go back to 3 again, and we'll go to AF, and that's how the console.logs log them out, as you can see in the console. So we have A, AD, ADG, ADH, ADI, AE, AEG, AEH, AA, AEI. I get a little head spun on trying to say all these vowels. So that's how the algorithm works. It's a tree-based algorithm, and I found that to be the easiest way to think through this. So there you have it. Copy and paste this code, work on the console.logs, and see if you can diagram this out with a tree. Hope that helps. Thanks for watching.